8, 7, 6, 5, 4, 3, 2, 1.
Hello there, and a very big welcome to Road to Space. We're live at the European Spaceport in French Guiana to launch the next 32 Amazon LEO satellites, travelling on board an Ariane 6 rocket, flight number VA268. Amazon's designation for today's mission is LE-02, LEO Europe 2, as it's the second of 18 launches using the European launch system to help grow the Amazon LEO constellation and connect more people to fast, reliable internet worldwide. It's also the second time we're using the most powerful version yet of Europe's rocket, Ariane 64, with its 4 boosters. And over in mission control, the teams are on console. They're about 16 kilometers from this pad inside what we call the fishbowl, that protective glass that you can see there. I'm Katie Haswell, and joining me is our rocket expert from Arianespace, Loïc Leroy. Great to have you with us, Loïc.
Great to be here with you, Katie. Hello, everyone.
And Loïc, how's everything looking? What's been happening so far?
Well, so far everything's looking good. We have the status panel green for the launch. We have targeted now the end of the launch window for today, so we have a new H0, but everything is in track, and the teams are very focused to have this liftoff coming up.
So, flight number VA268 has an exciting journey ahead. Loïc and I will be with you all the way. Of course, we'll be getting a good look at our launch pad. Here it is, the dedicated Ariane 6 launch pad at the European Spaceport in French Guiana. There's our rocket on the pad with its 4 boosters and the satellites up at the top.
And we'll go also to the Launch Control Center, where we have all the teams preparing the launch. They are in charge of all the operations, both on the rocket and on the launch pad. You can see the teams here in ArianeGroups preparing for the liftoff.
We'll also be heading over to France and seeing their colleagues back in Paris, just outside Paris actually. It's called Space Code, and these teams are at the ArianeGroup headquarters, working in parallel, supporting the teams at the Guiana Space Center.
Yes, and back to the French Guiana and the spaceport, we'll have the quick look telemetry teams working on the launcher telemetry, so they will report to the mission control the very heartbeat of the launcher during this flight.
And they will be very much involved after liftoff. Let's go inside the Mission Control Center now, inside the fishbowl, to David Caballeros. David is the CEO of Arianespace. David, thanks for coming to chat with us. How are operations progressing for launch?
Hi, Katie. Everything is on track. Our team here at the Guiana Space Centers have performed the final checks. Every systems are green, the weather conditions are favorable, so now Ariane 6 is standing on its pad, equipped with 4 boosters and ready for the launch.
And David, tell us a little bit more about our passengers for today's ride.
Yeah, absolutely. So today, Ariane 6 is carrying on board 32 satellites for our client, Amazon LEO. This is the second launch within a series of 18 that we are doing for Amazon. And I must say that we are very, very proud to support Amazon's ambition to deploy high-quality connected services worldwide.
And David, this is the 7th launch for the Ariane 6 launch vehicle, the rocket. Why is that important?
Well, it demonstrates our ability to quickly ramp up our launch cadence and also to deploy large-scale telecommunication constellation. So I would like to thank our Amazon clients for their continued trust.
Indeed. Thank you very much indeed, David. Best wishes to you now and to all the teams as we get closer to launch. David Carolus, thank you. So, Ariane 6, as we said, has already lifted off 6 times, each launch delivering its satellites absolutely flawlessly. It comes in 2 versions, as we've heard. We've got the 62 version, which has 2 boosters, and the 64 with 4 boosters. We are indeed flying the 64 version today, Loic. It's very powerful.
Yes, it's the second time we're using it, and it's the most powerful rocket in Europe. And it has been designed to deliver over 20 tons to low Earth orbit. This is the kind of orbit we are targeting today with our 32 Amazon LEO satellites. And we definitely need that extra power to lift off.
And if you look at the top of the rocket, you can see the pointed section. We call that the fairing. We have 2 versions of that as well.
Yes, another versatility feature of Ariane 6 is that we have 2 types of fairing, a rather short one of 14 meters and an extended version of 20 meters that we are using today as we are accommodating a lot of passengers, 32 of them. We need also that extra length to be able to fit all our satellites inside.
Indeed, so we've got the most powerful version yet of the launcher and the long fairing with our satellites inside. They are scheduled to lift off in just under 22 minutes' time. What's going to happen after that?
So we'll start our journey to space today with the ignition of the 4 boosters of the Ariane 6 rocket alongside the main Vulcan engine. We will lift off from the coast of French Guiana towards the North Atlantic. Then about 2.5 minutes of flight, we will separate the boosters and we'll continue the journey with the propulsion of the main Vulcan engine. About a few seconds after that, we will be exiting the atmosphere, and so we will be able to separate the fairing that is protecting our satellites right now. About 8 minutes of flight, and we will be able to shut down the Vulcan engine. We will have finished with the propulsion on this stage, and we'll separate the main stage, leaving the floor to the main upper stage, which is equipped with the Vinci engine. It's a reignitable engine. We'll use it 3 times during this mission, and the first boost will be about 11 minutes duration. We will then have a coasting phase or ballistic phase. We will reach the ground station in New Zealand and be able to have a second boost of the Vinci engine, a very short one, to be on the right orbit to deliver our satellites. So the separation sequence itself today will last about 25 minutes. It will be divided in 12 steps. We will separate the satellites 3 by 3, 2 by 2, and then eventually the last one will finish over the Atlantic. And once the commercial mission is over, we will enter the last phase of our mission for Ariane 6, which is a third boost of the Vinci engine, and then preparation for re-entry into the atmosphere above the Pacific Ocean. We call it the passivation phase. And this way we don't leave any debris into space.
So that's the plan for today's flight, for today's journey. But right now, the 32 Amazon LEO satellites are nestled inside our rocket, waiting to start their ride. And Amazon LEO is Amazon's low Earth orbit satellite network, isn't it?
Absolutely. The mission is to connect the world through a constellation of satellites in a low Earth orbit, so close to Earth, and they will be delivering fast and reliable internet to people, businesses, and communities, and that's beyond the reach of existing networks.
And even in major cities, getting online isn't always as simple as it sounds. I can vouch for that, living in London. I can walk down the street And in one street I can have great service, and the next street I can find I'm getting really terrible data connections.
Well, surely Amazon Leo can do something for you. But no, seriously, that's true. That poor internet connection that we sometimes face is really a truly invisible barrier, which determines who can learn, work, participate in a world which we increasingly depend on being online, for sure.
We do indeed. So imagine getting high-speed broadband literally wherever you are, whether you're in a remote village, a city street, or even at home. Amazon Leo's momentum continues to accelerate, from signing partnerships across a wide range of industries to plans to bring connectivity directly to mobile devices. And all of this is in the service of one mission: connecting everyone, everywhere.
Amazon Leo. Several years ago, Amazon set out to build the most advanced satellite system in the world. From the ground up, they designed and built everything. The satellites, the customer terminals, and the network architecture to connect them all. Relentless work, precision, innovation, and commitment. Built over years of focused effort. Today, this team wakes up every morning driven by the same ambition: delivering fast, reliable internet to people, businesses and communities beyond the reach of existing networks. What started as a vision is now in production. A single system built on 3 pillars: ground infrastructure, satellites operating low Earth orbit, and high-performance customer terminals designed for every need. Amazon Leo is scaling fast, building a new era of internet with full-rate satellite production running and over 100 launches on its manifest. From Europe's spaceport in French Guiana, Ariane 64 rises into the sky, carrying 32 Amazon Leo satellites beneath its fairing. With today's launch, we add another 32 satellites in a single heavy-lift mission, accelerating deployment an initial constellation of over 3,000 spacecrafts. Operating at around 600 kilometers above Earth, Amazon Leo brings connectivity closer to everyone, everywhere. A remote classroom that no longer freezes, a medical consultation without interruption, a small business in a rural town reaching customers across the globe, enterprises connecting offices across regions where traditional networks fall short, airline passengers staying connected at 35,000 feet, emergency teams connected where no infrastructure exists. Amazon Leo is designed to serve them all. With 4 boosters and unmatched lifting capability, Ariane 64 doesn't just launch satellites, it brings the future closer. Each launch adds capacity and extends the reach of the Amazon Leo network, strengthening performance with every mission. High-speed connectivity, expanding mission after mission. Amazon Leo is connecting more people, more businesses, and more communities around the world. Stay tuned from Kourou.
Gosh, and the Amazon Leo constellation is growing fast. They already have 270 satellites in orbit, and we're going to be adding another 32 of those today. So that'll be bringing the constellation to over 300. That's quite a milestone. Joining me to tell us about all this is Martijn van Delden, who is the head of consumer for Amazon Leo in Europe. Martijn and his team are responsible for bringing Amazon Leo's connectivity solutions to households across Europe. So that's a very important job, Martijn. Thank you so much for being with us. Looking at the countdown, we are 14 minutes and a half to launch. I wonder how you're feeling right now.
Well, first of all, thanks for having me. This is super, super cool to be able to be here. We're obviously excited about every launch we do, we feel a strong commitment to getting it right. I would say today's a little bit more special. Just 2 days ago, Tuesday, was the anniversary of our first launch. So within a year, we've been able, as you just said, to launch over 200 satellites. If today goes well, we'll get to over 300. That's 11 launches in just over 12 months, which is incredible. I believe it makes us the fastest deployed new constellation. So yeah, we're incredibly excited. We're also incredibly proud of all the work that our own teams are doing, but also all the hard work that our partners such as Arianespace are doing to support this mission.
And yeah, I mean, you must be. It's very, very impressive,
Absolutely.
isn't it? Martin, you're European, and you're also defining how Amazon LEO comes to Europe, if you like, brings the services to Europe. So, I mean, does today feel a kind of a little bit more personal for you in a way?
It absolutely does, yes. I'm Dutch. I'm actually from an area in Holland that is pretty well connected. My wife's Italian. Her family lives in a small village on a hillside, which doesn't have that connectivity, and just shows how easy it is to take good connectivity for granted. And those are the types of communities we're doing this for, whether it's rural communities, people on islands, people on mountainsides, really those types of communities we want to connect. Plus businesses, remote farmers, remote construction projects. That's really the mission. And then looking at, it's a European rocket with a European supply chain launched from European soil. Yeah, that brings it pretty close to home. It's very, very exciting.
And if your wife's Italian, I'm hoping you get some very good food.
Usually, yes, absolutely.
In her village. Martin, every mission has its own identity, it has its own story, whether it's the technology, whether it's the mission patch, whatever it is. Are there any ideas? Was there any innovation, anything that inspired you guys when creating this mission?
Yes, there are. If you look at the mission patch, you'll see a little airplane. So when we took a step back and thought about what Amazon LEO is about, it's about seamless global connectivity wherever you are. And I think the best way to show that is even in a moving plane, thousands of feet up in the air, you can stay connected. So the team's really connected to that. And the icon of the plane really displays the movement, the seamless connectivity, and the global aspect of the constellation we're launching. Nice,
I like that story. And what is it about this technology, would you say, that's going to actually really kind of change people's lives, if you like? Or, what is it about the technology that makes you excited?
Sure. To me, it's how it all comes together. So we have tons of innovation, whether it's in the satellites, the antennas, the ground infrastructure, the way we're working with AWS for our networking. I think if you bring that together and you add in the customer obsession that Amazon has, the trust that people have in Amazon to deliver, I think that's what really will drive the value for our customers. And yeah, we can't wait to get it in our customers' hands.
Indeed. So what's next?
We'll keep building. Job's not done. As Amazon, we have a mission to be the most customer-centric company in the world. When you see that there's billions of people that lack access to one of the fundamental technologies of our time, that's the mission that we're trying to solve. And our solution is Amazon LEO. So the mission as Amazon LEO is to have fast, reliable connectivity wherever people are, to allow communities and businesses to thrive. So today is a big step. It's a very important step, but it's one step of many on what will be a decades-long mission to deliver on that mission.
And what a mission it is. Thank you very much indeed, Martin, for coming and talking to us about it.
Yeah. Thank you for having me. Cheers.
Thank you. So we are coming up now to the next big moment. That will be the final weather check. That comes at what we call a T-10, 10 minutes before launch. We are on the Amazon rainforest, on the edge of the Amazon rainforest in French Guiana, which is on the northeastern coast of South America. And you can see it there on the screens, the map at the bottom there. And it does get very hot and humid. The weather conditions do have to be right, though, for a launch to go ahead. Loic, what kind of things do we need to actually monitor?
Well, Katie, mostly two main things. The wind, first of all. We want to monitor it both on ground and in flight in high altitude. We monitor the speed and the direction, and it's mostly for safety reasons. Then there's the lightning risk. Of course, on ground, we are safe. Maybe you have seen these metallic structures, towers on the pad, which are protecting right now our launcher. But of course, when we will be flying across the atmosphere, we don't want to be struck by any flash of lightning. That would be damageable for the avionics. And if you wonder about the shower rains of Amazonian climate, there's no problem with that.
Well, I'm very glad to hear that because it rains a lot in the Amazon rainforest. So the fact that rain is not a problem for our rocket is very good. So what techniques do we use? I mean, we have a weather station, don't we, here?
We do. We have a weather station and staff dedicated to this full-time in the spaceport. And they're using balloons. They inflate balloons equipped with a lot of sensors, and they will this way get feedback on temperatures, speed of wind, altitude, and direction, and so on. And probably the weather forecast is one of the fewest elements that we don't fully 100% capable of monitoring. But today the weather conditions are green, so it's nice.
Indeed, the weather, we're in the lap of the gods there. We can prepare more than one mission at a time here at this spaceport.
Yes, indeed. We've been very busy because we are preparing several missions in parallel, for example, for our Amazon LEO customers. And yes, we want to be flexible as such to be able to respond to the need of our customers.
You can see all our status panels are green there. The weather status panel is green, so I'll go for launch in the weather department. The launch campaign is the process of preparing the rocket and the satellites. What's been happening?
Well, first of all, the 32 Amazon LEO satellites have arrived mid-March in French Guiana, so about 1.5 months ago. They were transported to the Space Center. And in parallel, the elements of the launcher, the different parts, have been produced in Europe and sailed over the Atlantic to French Guiana on this specific boat that you see, the Canopy. Of course, the parts of the launcher have been transferred as well to the spaceport, and that marked the beginning of the launch campaign as such. The first very big step was to assemble the two main parts of the central core, so the upper and lower stage. You can see here the ArianeGroup teams assembling with a laser precision these two main parts. Then this assembly is transferred to the launch area. You could see that it was assembled horizontally, and of course we need to tilt it vertically to be able to welcome the other parts of the launcher. This is done on the launch pad in a dedicated mobile gantry building. The boosters on their side were prepared separately in safe areas, and once they have been filled with propellant, they have been brought to the launch pad and then assembled on the main core. We have 4 of them today for our mission. In parallel, we have been preparing the fairing. You can see here the logo of our customers being placed on the fairing. The satellites themselves are prepared in a separate building very safely, and they are then transferred to the fairing facility once they are ready. The whole composite, the fairing and the satellites, are transferred then to the launch pad, and of course we have that big moment of mating of the fairing on top of the launcher, which marks, let's say, the final assembly, and we have now a proud Ariane 6 standing on the launch pad.
A proud Ariane 6 indeed, and we could see there on the ground as we looked at those pictures that there's been a bit of rain in Kourou recently. There they are on the pad, the Amazon LEO satellites tucked up inside the fairing with their seatbelts on in first class, waiting patiently for liftoff. Everybody before launch is looking at the status panels. We saw them earlier, all the teams here in the Mission Control Center. The panneaux des verts, as we call them in French. What do they show us?
Yes, as you said, it's a very important board which have several tabs reporting the status of readiness of different parts of the launch component.
À tous de DDO, attention pour la séquence finale lanceur. Top, H0 moins 5 minutes.
Our range operations manager, Xavier Nehru, there announcing the beginning of the synchronized sequence. It's the final go, no-go decision. You'll be hearing Xavier's voice throughout the launch, calling out the major milestones. Everybody across the base will be listening out for him. Obviously, there are lots of facilities, lots of people here at the base, so everybody needs to be focusing on his words. So we are now in what we call the synchronized sequence or the automatic sequence. What's that and what's happening?
Yes, we are in the important moment of the chronology when during these 5 minutes we will prepare the final state of the rocket. So step by step, the ground computers, which are handling a lot of operations right now, we are talking about activation of valves, pressure and checks, avionics, safety checks. They will leave the way to the onboard computer that will become more and more autonomous. And of course, at the end of the road, we have a fully ready launcher ready to lift off.
So we've got lots of teams here at the base. Obviously, we've been seeing the mission control team, but we also have another launch control center, which is closer to the pad. Number of different control rooms, as I said, and the base, we call it the range, all the different facilities, and here are the launch control teams.
Yes, they are the operational teams. So they are located about 5 kilometers from the launch pad. They are inside a kind of bunker, which is really reinforced, making them safe from the blast of the launch. And they have been sending all the commands to fill the tank, pressurize the systems, do basically all plant checks to confirm that the launcher is ready. Now they are leaving the way to the computers and the onboard computers of the launcher, which will become autonomous, but they will keep on monitoring all the parameters. We're talking about temperatures, pressures, electrical currents, and then they get feedback from this. And of course, in Europe also, you have this Space Code team that is supporting them, and they are looking over the data as well and making sure that everything is going on track.
Very important to have a double set of eyes, if you like, on the consoles. The more people, the better. Getting close now, laser focus across the base. We can see the cryogenic arms there, Louis, clamping onto the rocket. They are pumping liquid oxygen and liquid hydrogen into the launcher, and they're kept at extremely low temperatures.
Yes, indeed. We're using as propellant for the main and upper stage the liquid hydrogen and liquid oxygen. So we are talking about cryogenic fuels. Liquid hydrogen is minus 253 degrees Celsius. So for our US viewers, it's minus 423 degrees Fahrenheit. So pretty cold.
Pretty cold.
And in comparison, the liquid oxygen is only minus 180 degrees. So rather hot if you like.
Only minus 180. So the white smoke there, those liquids evaporating. We actually ignite the Vulcan engine 7 seconds before we ignite the boosters. That's just to check that it's working fine, so you can count to 7.
À tous de DDO, attention pour moins 1 minute. Top, à 0 moins 1 minute.
We are 1 minute to launch. Our very best wishes now to all the teams and to our 32 Amazon LEO satellites as they get ready to start their journey. Good luck, everyone.
Good luck, Ariane 6, and good luck, Amazon LEO.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Allumage des ESR et décollage. La propulsion est nominale.
forest. Good views of our most powerful version of the Ariane 64 rocket, and we can see those 4 engines there, Loïc, the 4 boosters. Yes. They're doing all the heavy lifting right now, aren't they?
Yeah, right now they are responsible of more than
La propulsion est
85%
nominale.
of the first liftoff. So basically they are doing the job right now. Of course the Vulcan engine is working as well. And just to give you a few figures, each booster carries 142 tons of solid propellant, and it burns in only about 2 minutes. So imagine the power of these boosters. Once they have done their job and they are basically used all their propellant, they will be separated, and the separation sequence of the boosters is initiated automatically by the onboard computer. It detects when the acceleration of the launcher indicates it's time for separation. And today the separation should occur at around 86 kilometers of altitude.
Tous les paramètres à bord sont nominaux.
Good views there from our onboard camera. The range operations manager is telling us that everything is going nominally, everything is going according to plan. And I think we're going to see, I'm hoping that we will see those boosters separating with the cameras.
Yeah, really nice views. Huh? We're lucky the clouds have disappeared a little bit.
It was a bit cloudy when we lifted off.
At the beginning, yes. Didn't see much, but now it's really nice.
Coming up now to the separation of those boosters.
Séparation des ESR.
Quite see them there. We have confirmation. The range operations manager has confirmed that we've separated our boosters. So those live images coming to us with a few seconds delay for technical reasons, but that's the boosters moving away.
Yes, it's really nice to see these images. It's always a reward for the engineers who have been working on this project for many, many months. And we have the data, of course, but this kind of images is always a great reward.
La trajectoire est nominale, tous les paramètres à bord sont nominaux.
Next up will be the jettisoning of the fairing. Everything's going normally. The fairing, the top section of the rocket, we saw it on the ground.
Séparation de la coiffe.
Yes, it's a kind of a nose cone of the rocket, and it protects the satellites from the dust, humidity on ground, and of course during the crossing of the atmosphere, the friction of the air, which would be damageable for the satellites. So once we have exited the atmosphere, we can just get rid of the fairing gently. We can see it now.
Yep, we've had it confirmed from the range operations manager. Look how those parts flex as they fall. It comes away in 2 halves, doesn't it?
Yes, 2 halves, and this kind of behavior that you see, the way they move is called the breathing modes, because it's very flexible to make sure that they don't break when they separate. But on the other hand, it's also very robust to be able to sustain all the mechanical loads, all the aerothermal loads that they have during the atmosphere, which are really important. So it's a very ingenious design, a mechanical design, this fairing. It's both flexible and robust at the same time.
Quick word about what you can see on the screen here. On the right-hand side, our trajectory. He's telling us that everything's going normally. The trajectory is the green line. The cross is the actual position of our launcher. And then below that you can see our altitude, 175 kilometers and climbing, our distance from the pad, and our speed at the moment, Loïc, we're traveling at, well, over 3 kilometers per second.
Per second, yes. Pretty fast.
Pretty fast. So the captain has now switched off the seatbelt signs. We can see our satellites in this animation on the bottom right of the screen. There's the big tank of fuel, the main stage, and Loïc, we can see our satellites there.
Yes, they are exposed to the outer space for the first time now because the fairing has been removed, and we can see the 32 satellites of Amazon LEO. They are assembled on a kind of mast or pole that is the satellite dispenser. It is provided by Amazon, and it is accommodated on a conical structure that you may see in black, which is called the launch vehicle adapter. And this adapter has been specifically reinforced for this mission, since we have a very heavy stack of payload on top. And now you can have a closer view of the Vulcan nozzle. The propulsion right now is done by the lower stage, and we are increasing our altitude. And as you said, Katie, we can see the track of the launcher in yellow, which is perfectly fitting with the planned trajectory in green.
And these animation images on the bottom right are a simulation of what's been planned.
A simulation, indeed, yes. It's computer-generated images, but they are really a reflection of what has been planned in terms of mission analysis and trajectory and attitude of the launcher also. So it really is realistic. You have a good view of what's happening right now in space.
So he's confirmed the acquisition of signal at the naval station. We are tracking the rockets using telemetry. We have ground stations along the flight path, and the rocket is sending a signal to those tracking stations as it flies over. Basically, it's talking to us. It's communicating, if you like.
Yes, it's absolutely right. We are in constant communication with the launcher. It sends us a lot of details about its functioning and, of course, its trajectory and so on. And we are using, as you said, ground tracking station all over the globe. But right now, we are using a tracking station on the sea in the Atlantic. It's called the Naval Tracking Station. So as you guessed, it's a boat and it's equipped with 5 meters diameter antennas mounted on a kind of stabilized platform. So we make sure that even if the weather at sea is not so great and a bit wavy, we have a steady and reliable signal to get. And all these stations, they are managed by the CNES team, so the French Space Agency, and they are managing all these stations all around the globe.
And I guess it's very useful to have a tracking station on a boat because you can take it where you need to, as well as stabilizing it. So the launcher has checked in at the Naval Tracking Station and said hello to the teams there. Coming up to the next big moment, that's the switching off of the Vulcan engine.
Fin de mission sauvegarde. Séparation LLPM. Premier allumage Vinci.
And we have the separation of the main stage confirmed, and we have confirmation now of the switching of the Vinci upper stage engine. There we can see the images on the live camera of the main stage falling away.
Very nice to see this kind of images. Yeah, you can see the lower stage is being ejected and passivated before it re-enters the atmosphere.
So this is a really important moment, isn't it, switching on the upper stage engine?
Yes, we are into the next great phase of this launch. We are using the upper stage, which will be the stage that will raise our altitude, and eventually, with a second boost later on, we will have the last target orbit for our satellites. So now we are performing the first boost. We will boost for about 11 minutes, raise our altitude, and of course, trying to go to the point where we will be able to deliver our satellites.
We're looking here at the camera. We can see the upper stage engine just on the right-hand side there, and kind of slightly glowing as it's burning. So the upper stage is now in charge. Its job is to deliver its passengers to their required dropping-off point, if you like, in space. A bit like an orbital bus driver, isn't it?
Yeah, luxurious.
A luxurious one.
Bus driver, yeah.
With lots of passengers on the bus.
A lot of passengers, and with this Vinci engine that we're able to reignite, we will use 3 boosts for this mission. We are very flexible on this kind of mission, so we will be able to deliver a constellation at the right place at the right time. And this is a really interesting feature of Ariane 6 as such. We are using also cryogenic fuels for this engine. So once again, oxygen, liquid oxygen and liquid hydrogen.
So he's telling us, the range operations manager telling us that the trajectory is nominal, it's normal, and all the parameters on board are nominal. So that's good news. Everything's going according to plan. The tracking stations collect the data from the rockets, and they actually relay it to the teams at the Guyana Space Center, the quick look telemetry teams. We saw them briefly at the beginning. Their tracking station is called Galileo.
Yes, it's a tracking station just outside of the spaceport on a small hill, and they are now collecting all the data in real time that the launcher is sending. That includes, for instance, status of the engine, the speed of the pumps, the pressure of the tanks, the engine thrust, and of course a lot of information on the trajectory, making sure that we are on the right track. And they compare all this data to the actual planned trajectory and simulations. So it allows us to analyze in real time the launcher's behavior, and they report to the mission manager in real time. So we get this feedback from the range operation manager based on their analysis.
You can see them on the bottom right of your screen there, focusing very, very hard. So it's a very demanding job because there's an awful lot of information coming in at once, isn't there?
Yes, a lot. We have, as you see, many people from CNES, ArianeGroup, and from Arianespace.
And they share that information on their internal comms loop, which is then transmitted to the range operations manager, who can then make the announcements. We're going faster and faster, Loïc.
Yeah, 5.6 kilometers per second. Don't make me do the maths, please, in kilometers per hour, but it should be rather like 18,000 or something kilometers per hour. So it's a good way to commute. I wish I had that for work.
What's our flight path?
So our flight path today, as we of course said before, we have left French Guiana coast. We have crossed the Atlantic, and we will go above Central Europe, then down Southeast Asia, and above Australia and New Zealand, when we will be able to have the second boost of the Vinci engine. Then we'll have a second fly over South America and the Atlantic, and that's the part when we will be able to separate the spacecraft from Amazon LEO. Then the third big step of this mission will be the passivation and the re-entry, which will happen after another lap of the Earth. It would be happening above the Pacific Ocean.
So we've had the confirmation there that we've picked up the signal at the Santa Maria tracking station, which is in the Azores. Most of the Ariane 6 rockets are manufactured in Europe, and the sections are transported to French Guiana by boat. But it's not just any boat.
No, indeed, it's a very innovative boat. It's called Canopée, and it uses both fuel and wind to cross the ocean. You can see on the screen the 4 sails, these 4 masts on the platform, and they use the wind power to save the fuel. We are already saving 40% of fuel, which is a great step for us to reduce our carbon emissions for this transatlantic crossing. It's been sailing around Europe, as you said, collecting the different sections of the rocket that are manufactured in Europe, and then they carry them across the Atlantic to French Guiana. And Canopée is a nice nod to the rainforest canopy, which is basically the ceiling of the rainforest.
A very nice nod indeed, and now we have a lovely view of the riverside part of the canopy, the Amazon rainforest canopy. So the tracking station in Santa Maria is now locked onto our rocket's signal. The teams there are tracking our launcher. As I said, it's a Portuguese island in the Azores, in the Atlantic. So let's turn our attention back to our passengers now. You can see them there, our 32 Amazon LEO satellites, as they hurtle through space on their way to their destinations. I'm delighted to be joined by Johan Benard. Johan is the Public Policy Director, Europe Digital at Amazon. Johan, thank you so much for coming to chat with us.
Thank you for having me.
Well, it really is our pleasure. Johan, we are, 14 and a half minutes now into our journey. Anything standing out to you?
Well, I've been shaking a lot for 14 and a half minutes, so I'm not sure I'm done yet with it, but it's amazing to see, the liftoff, and of course the mission is still ongoing, but it's just incredibly exciting. And, I've been supporting Amazon LEO for 7 years now, and so to see it go live for real, it's just crazy.
Yeah, that's 7 years. And now here we are today launching. That must be quite an emotional experience. there's an awful lot of expertise in Europe, and this mission brings together a lot of the European capabilities. How important is this mission and this partnership for Amazon LEO?
Well, it's really crucial. You know, it's a global project, Amazon LEO, but it embarks a lot of European technology, and of course, core to that, you know, to that contribution is Arianespace and Ariane 6. But through the Arianespace and ArianeGroup supply chain, actually more than 600 businesses across Europe contribute to that project. And there is more because we also manufacture, for example, our satellite dispensers in Europe. So this is really a teamwork from Team Europe.
Indeed, and every mission is teamwork, isn't it? Because there are so many people involved, all working together. Also, I mean, there is also the economic and the industrial side to this. Yeah. I mean, how important is that?
Well, I think it's pretty important, and there are some metrics about that. There is a very significant contribution of that partnership to the European space industry, and that results into thousands of engineers and highly skilled technicians being involved in that project. That also kind of relies on innovation across 13 different European countries. And so that's great for the European space industry. That's also great for the European economy at large. It's billions of additional GDP. But most importantly, because at Amazon, you know, we are customer-centric, it's great for people. There are tens of millions of households still in Europe who are still waiting for reliable broadband connectivity. There is also a key use case for a number of businesses, including at times where redundancy and resilience are absolutely crucial, for example, in case of natural disaster. And this is exactly what Amazon LEO will provide to Europe, that connectivity, that resilience, that redundancy that will serve the communities. And so I will finish here by saying that I'm also very, very much aligned with David Cavalloles, who said after the first launch in February that this partnership actually contributes to European strategic autonomy, because with that new communication system that will provide resilient, reliable communication, with that contribution to the European space industry and the economy, well, that's exactly what we do.
Yeah, very, very important. And what would you, anybody who's watching this now, watching this launch, watching this mission unfold, what would you like them to take away from this?
Well, I'm proud. I very much believe that people who have seen the takeoff are proud as well. Of course, it's still ongoing, so we'll see how it unfolds for the rest of the mission. But that's, I mean, amazing to see the contribution of Europe to a global project like Amazon LEO.
Well, we're very proud to have you here, and thank you very much indeed for joining us, Johan, and very best wishes now for the ongoing mission. Thank you.
Thank you.
So, back to our flight. We are 18 minutes, coming up to 19 minutes into our journey, and coming up to the next big moment, which is, of course, the extinction of the upper stage engine, which we've just had confirmed there by our range operations manager. Loïc is back with us. Loïc, why are we switching off the engine now?
So right now we're on an intermediate orbit, an elliptical orbit, so kind of the shape of an egg. The closest point is the perigee, which is 150 kilometers from Earth, and the apogee, which is the furthest point, is at 465 kilometers, and that's the altitude we are targeting today to deliver our Amazon LEO satellites. So it will take us about 52 minutes to climb up to that highest point, and then once we have reached that, we will be able to switch again the engine for a very short boost to make the orbit circular. And that's the targeted orbit for injection of our satellites today.
And the next tracking station scheduled to pick up the signal will be in France at Ossaguel.
Yes, in the south of France, near Toulouse. So you probably know Toulouse is a great city of aerospace industry in France. It's also a really nice city to visit, made of pink brick walls. If you have ever visited, it's really nice, and honestly, there is also very good food.
It's got a lot going for it. The Pink City, I have visited actually, and it's lovely.
It's lovely, yes.
Right, we are now going to take a break. We, by the way, had the confirmation there that we have picked up the signal at the Orsegal tracking station. You can see there we're actually flying over, heading towards France, and then I had a good view there actually of my home country, the UK, flying very close to London, my home city. Right, we're going to take a break now. We will come back in about 45 minutes' time, so don't go away. Stay tuned.
Stay tuned.
Fin d'acquisition de la télémesure par la station de Santa Maria. Tous les paramètres à bord sont nominaux. fin de visibilité par la station de Sagel. Trou de télémesure attendu. Acquisition de la télémesure par la station de Nunorcia. La propulsion est nominale, le pilotage est calme. La trajectoire est calme, tous les paramètres à bord sont nominaux. Le pilotage est calme, tous les paramètres à bord sont nominaux. Fin de visibilité, New Norcia. Trop de télémesures attendues. Acquisition de la télémesure par la station d'Awarua. Le pilotage est calme, tous les paramètres à bord sont nominaux.
Welcome back to Road to Space. We've been watching there fantastic images of the liftoff over an hour ago from the European spaceport here in French Guiana. I'm Katie Haswell. Loïc Leroy, I'm delighted to say, is still with us, our expert from Arianespace. Amazing images there, weren't they?
Yeah, amazing. You'd see that kind of new sun during the Amazonian night. It was really nice to see.
Ariane 64 is transporting our 32 Amazon LEO satellites to space.
Yeah, that's right. They're traveling on board Europe's most powerful rocket. It's Ariane 64 with 4 boosters, and today is the 7th flight of Ariane 6.
And a reminder of what the Amazon LEO constellation is all about. Amazon LEO is Amazon's low Earth orbit network. It's designed to provide fast and reliable internet to customers and communities beyond the reach of existing networks.
Yeah, the network is built around an initial constellation of more than 3,000 satellites, so they will be working together in a tightly coordinated movements, and they achieve a common purpose, which is providing reliable broadband coverage.
And that's super important. Ariane 64 lifted off an hour and 9 minutes ago. Just talk us through what happened, some of the highlights, and what we can expect coming up.
So we lifted off from French Guiana in Kourou, then towards the North Atlantic. We crossed the Atlantic and we separated the boosters of Ariane 6 about 2.5 minutes of flight, propulsed then with the Vulcan main engine for about 8 minutes. When we exited the atmosphere, we have get rid of the fairing, which was protecting our satellites. Then, after the end of the propulsion of the Vulcan engine, we have separated the lower stage, leaving the way for the second stage, which is the upper liquid propulsion module. It is equipped with the Vinci engine that you see on the screen. It has been already ignited twice. And the first boost was 11 minutes approximately to raise our altitude. And then we will have a second boost on visibility of the ground station in Awarua coming up. And then we'll be in the right targeted orbit for the separation of our satellites. The separation itself will last 25 minutes and will be separated in 12 steps. We will separate the satellites of 3 by 3, then 2 by 2, and eventually the last one. Then this will mark the end of our commercial mission, and we will have a next phase, which is the re-entry into the atmosphere with the passivation phase. We'll have a third boost of the Vinci engine for this purpose. We will re-enter above the Pacific Ocean, and this way we will not leave any debris into the space.
A reminder, if you're joining us, the information on the right-hand side of the screen is coming in from the telemetry from our rocket, the trajectory at the top there, the actual position of our launch vehicle. And below that, our altitude, our distance from the spaceport and our speed. We are hurtling right now through space at 7.23 kilometers per second. Coming up to the next big moment, Loïc, the switching on of the Vinci 1 engine.
Deuxième allumage, Vinci.
That's how it looks there on the animation. And we have the confirmation from the range operations manager that it's switched on. It's a short boost, isn't it?
Very short, yeah, 18 seconds. We only need to make the orbit become circular. We are already at the right altitude. You can see on the screen about 470 kilometers.
And he's confirmed it's now switched off. So, well, things are about to get interesting for the Amazon LEO satellites, because the next step will be the start of the separation sequence that you've been explaining to us, the delivering the 32 satellites in 12 separations.
Yes, indeed, 12 separations, and the onboard computer is now fully autonomous, so it knows perfectly when and where to drop our passengers on the supposed orbits. We will get news from that when we reach the next tracking station. It will be in French Guiana. It will be in about 25 minutes from now. We will have done by then another lap of the Earth, the first lap of the Earth, actually. And so we will proceed then with the separation sequence.
So we're going to take a break now during that 25-minute wait, our coasting phase, because we're traveling without the engine, so we're in what we often call a ballistic phase. And we will come back to you just before we check in at the tracking station back in the spaceport in Gallio. So see you back here in 25 minutes.
Perte de la télémesure par la station d'Awaria. Attendu.
Hello again. Welcome back to Road to Space. I'm Katie Haswell.
And I'm Loïc Leroy from Arianespace.
We are 1 hour and 38 minutes into the journey of 32 Amazon LEO satellites on board Ariane 6 for Europe's rocket.
Yes, they're on their way to join their fellow Amazon LEO satellites in space and grow the Amazon LEO constellation.
And we are scheduled to have delivered the first 15 satellites onto their orbits. Lots of passengers on our bus today. That's the animation. That's how it looks like. All our passengers, or some of our passengers, getting off at different bus stops, some of them getting off at the same bus stop.
Yes, exactly. We have our bus driver is the upper stage of Ariane 6, and he knows exactly when and where to drop off its passengers, the Amazon LEO satellites. So it's autonomous. It knows perfectly when to release the satellites, and we are waiting to go back in the range of the Galileo ground tracking stations here in French Guiana. We will have done a lap of the Earth by then. And once we log the signal onto the Galileo station, we will be able to download all the telemetry data from the launcher and get feedback from it. Then, of course, the telemetry teams will quickly analyze this, and they will continue on doing this until the end of the mission.
And we've got the signal now at the Galileo tracking station confirmed, so that's very good. So if you are joining us now, Loïc, maybe you could explain to people what the separation sequence is once again.
So we have 32 satellites to separate. We will separate them from bottom to top, 3 by 3, then 2 by 2, and finally the last one. So the 9 first separations will be trios, and then we have 2 and 1 satellite to separate. The separations basically is made by separating command. We are now the satellites attached to the dispenser. This is the kind of mast that you see on the screen. And we release the system by a pyrotechnic device, and they are gently pushed away from the mast.
With a set of springs, I believe.
Yes, we're using springs to make sure that we have sufficient distancing from the launcher and also from each satellites towards each other.
So this is how it looks up there for separation number 6, our three satellites moving away from the mothership, and our range operations manager confirming that the separation sequence is ongoing. So yes, you were mentioning springs and pyrotechnics, so it's a very important process.
Yes, we have the onboard computer sending the separation commands, and then they are relayed onto this mast, this dispenser that you're seeing, and then we are able to release the satellites in a certain order that has been already predefined by the mission analysts. And we want to separate them at the right orientation, right velocity, and of course with the right distancing from each other and from the launcher.
We're coasting without the engine. Had a good view there from space of the beautiful ladder of Caribbean islands. We still have a little bit of propulsion though, don't we?
Indeed, yes. We have shut down the main engine, the Vinci engine, but we are using what we call the auxiliary power unit, the APU. So it's a small engine that gives a continuous thrust, low thrust to the stage. And it plays a critical role because it helps us maintain the upper stage trajectory and attitude. And also, it's a very important feature for this mission. It ensures a rather quick separation sequence and ensures that the satellites do not collide immediately after separation. So it's a very good innovation for Ariane 6 that allows us to address complex missions like the one we are having today with a constellation.
Not to be confused with the auxiliary power unit, which is on the tail of an aircraft. Very different thing. Coming up to our next separation, separation number 7. So the naval tracking station is now keeping its eye on events and monitoring what's happening up there in space. We did a lap of the Earth, came back into the range of Galileo. We can see someone holding up the mission patch there, which is a really great mission patch, which we were hearing about earlier. So right now it's our boat. We're back over the Atlantic.
Exactly, yes. We can see the Caribbean islands on the animation. We have lifted off from French Guiana, from the northeastern coast of South America. We have headed northeast along the Atlantic towards Europe, then Southeast Asia and Australia and New Zealand. And we are back, as you said, Katie, above South America and now the Caribbean. We will cross the Atlantic again, and we will have the full sequence of separation completed above the Atlantic. And then after that, a few moments later, we will have another phase, which is the orbitation maneuver with the third boost of the Vinci engine. And the purpose of this is to re-enter the atmosphere and to disintegrate basically the upper stage and not leave any debris into space.
Nice view there of the mast, as you say, the dispenser, which allows us to attach the satellites and also to eject them into space. A shout out to all the teams in the tracking stations who are doing such an important job monitoring all of these events. So we had Galileo, we had the Naval Tracking Station, and the next one?
Santa Maria in the Azores Islands. Then we have south of France, Osagel, then once again Australia, New Zealand, Nonorsha and Awarua. So a lot of teams involved in very different time zones. So thank you for them to be involved with this great launch. So thanks to CNES also, which is monitoring all these ground tracking stations.
Time for our next separation. Number 8.
Poursuite de la séparation Mazo-Léo.
Very nice visualization of our satellites moving away from the mast, the dispenser, the range operations manager there, confirming that the separation sequence is progressing. Gosh, this is another milestone, really, isn't it, for the important partnership between Arianespace and Amazon LEO. It's, as we were hearing earlier from the guys, it's really important.
Yeah, absolutely. It's the second of 18 missions for Amazon LEO with Arianespace. So we've been quite busy dealing with all these missions, and we are only doing the second today, but many more to go. So we are constantly upgrading the spaceport to accommodate this. And for example, we've given Amazon their own dedicated building to prepare the satellites. So we are always glad to have them with us at the Space Center and proceed with their numerous launches.
Yeah, indeed. Always welcome. And these are indeed very, very busy times at the spaceport. I mean, what are Arianespace's plans for the target launch rate for Ariane 6?
So as you know, we have performed 6 successful flights in 18 last months, and we aim to gradually increase this number of annual flights so we can meet all the needs of our customers. We have a rapid ramp-up coming up. We will accelerate this year and roughly double the number of launches compared to 2025. The target is 7 to 8 launches this year in 2026. And eventually, the launch cadence target is to have 9 or 10 missions per year, and we shall achieve this goal by 2027. And importantly, we have a great variety of missions that we can address, so telecommunications, Earth observation, space exploration, so many, many possibilities for our customers.
Very exciting missions. You can see our teams there at the CVI, the Quick Look Telemetry team at the Guyana Space Center, Galileo. Somebody's walking towards the camera there. And they're doing a very important job receiving the information coming in from the telemetry stations and tracking all of these events in real time. Separation number 9.
Poursuite de la séparation Amazon-Léo. Acquisition de la T-mesure par la station de Santa Maria.
Confirmation, we have now picked up the signal at the tracking station in Santa Maria, so our rocket is checking in there, saying hi to the teams, letting them know what's going on. And just a reminder for anybody who's joining us, Loic, the Amazon LEO constellation is Amazon's low Earth orbit network, and it's designed to provide fast and reliable internet to customers and communities beyond the reach of existing networks.
Yes, absolutely. Amazon LEO is now deploying thousands of satellites, and they are linked to a global network of antennas, as well as fiber, internet connection points on the ground. And the constellation will include satellites working together in a tightly choreographed mesh. And as you said, the intention is to deliver a low latency connectivity, which is a fast and a very steady signal for homes, businesses, emergency services, farmers, and even in aircrafts.
Yeah, really important. And life is almost impossible these days without good connectivity. So this is a vital, vital service. 3 more separation events to go. You can see the events on the left-hand side of your screen, on the right-hand side. A reminder there of our speed and altitude, our trajectory at the top there. The trajectory and also the list of satellites that have already been separated. Coming up to our next separation, number 10.
We will now separate 2 satellites at a time.
2 by 2, and then there will be one final separation with one lonesome satellite at the end. Here we go. Separation number 10 looks like that with these fantastic CGI images, the visualization of what's been planned for today's mission. So we've been hearing a lot about some of the changes and evolutions at the spaceport. What about the rocket itself, Ariane 6? I mean, that's changing and evolving all the time, isn't it? You're constantly making improvements.
Yes, indeed. We have today the Ariane 64 version, which is the second time we use this version. It's the most powerful, and it gives us a lot of flexibility, but we have also other innovations coming up. Of course, we benefit from the legacy of the previous Ariane family, which is a very strong heritage, and we are today refining our knowledge from each flight that we have successfully done previously, and we improve all the time the performance and the refinement of the launcher to address more complex missions and being able also to bring more satellites to different orbits for our customers.
There's a huge amount of expertise in Europe for space.
Yes, indeed. We have many partners all across Europe working together on the Ariane 6 program.
Any upgrades coming up that you can tell us about?
Well, we have the P160 upgrade, so an enhanced version of the booster that we are using today on Ariane 6. It's been developed with the European Space Agency, and it should be available very soon. This is a booster that will be carrying approximately 160 tons of propellant, so more loaded than the ones we are using today. And it will be a little bit longer, 1 meter longer, but basically the same interfaces than the ones we are using today. So it doesn't change the central core of the launcher. And we will have more performance, of course, associated to that. So being able to bring even more satellites to orbit.
Coming up on our next separation now. Teams we could see back there in the launch control center were standing and watching the mission. Confirmation that the separation sequence Amazon LEO is continuing. Our satellites, our last 2 satellites there, separating 2 by 2, number 11. So we just have 1 satellite left, Loic.
Yeah, a bit lonely at this time, but it will soon rejoin these companions in space.
Indeed, it'll soon be there rejoining its brothers and sisters, its family in the constellation. So what happens to the satellites once they're released?
So they are starting their real life, actually, and the Amazon LEO's team is working now to take over command of their newly deployed satellites. They are working 24 hours in the they are based in Redmond, Washington State in the US. So basically they are in charge of flying the satellites, which means managing the spacecraft operations. And right now they are taking over the mission. They are establishing contact with the satellites, which is important, of course. And then they will be conducting initial health checks, making sure that everything's all right before raising the orbit of the Amazon LEO satellites to reach the operational orbit, which is at 630 kilometers, or about 200 more kilometers than the injection that we are using today for the delivery of the satellite. And once they have gone this commissioning phase, as we say, they'll be able to start their actual job, which is providing the internet to all of us.
Very, very important job indeed. Just hearing there from the range operations manager that we went out of the range of the SNA tracking station, or we were being tracked by, and still being tracked by Santa Maria, but we've also now gone into the range of the Osagel tracking station. So we're back heading over France again as we head towards our final separation.
Fin de la séquence séparation Amazon
satellite heading off. And we have the range operations manager announcing that this is now the end of the separation process for Amazon LEO, and seeing some happy faces there in the Mission Control Center. The teams have been working extremely hard now for some time, preparing for today. But of course, we still have teams on the job, still working. We've got the teams at the Amazon LEO, teams taking on their satellites, and we still have teams in the quick look telemetry team.
Absolutely, yes. We have teams in the CVI team which are still working, because we are now entering the next phase of the mission, the last phase, which is the re-entry of the upper stage and the mast, also the dispenser, into the atmosphere. So we'll have a third boost of the Vinci engine and then re-entry in the atmosphere. Sorry. So this is all controlled again and under the very focused scrutiny of the team.
So where are we over the planet?
So right now we are coming back to Europe, and we are continuing our journey, and we'll have another ballistic phase for quite a while until we reach again Australia, and then we will proceed with the third boost of the Vinci engine and the passivation, which means that we make the tank being inert. We don't want to explode when we enter the atmosphere. We have a controlled, very controlled re-entry.
Still hearing from the range operations manager telling us that everything's going normally and according to plan, because as you say, we still have the mission is ongoing, the passivation process, and the teams at the tracking station at the Galileo tracking station at the Arianespace Center working on that now, still receiving the information coming in from the Osagel tracking station. The Pink City.
Yes, the Pink City of Toulouse, and the region is quite very nice. If you want to visit it, it's nice.
Let's go over now to David Cavaiolis, who is the CEO of Arianespace. David, thank you so much for coming back to chat with us. David, as the mission is ongoing, what can you tell us about the progress of the satellite separations, and how is everything going?
Well, as you said, the mission is still in progress, but I have fantastic news to report. First, Ariane 6 reached the targeted orbit, and second, the satellite separation for which we have data all happen nominally. So this is extremely positive. Now let's wait for the data from the other satellites. But by then, I would like to congratulate all the teams involved in this launch. This is a really amazing teamwork. And also, I would, of course, like to thank our customer, Amazon LEO, for the continuous support, for the trust. This is a real pleasure to work with you.
Indeed. And David, what's next for Ariane 6?
Well, we have quite a lot of news because this is my pleasure to announce today that the upcoming launch of Ariane 6 will be once again for Amazon LEO, and for the very first time we will equip Ariane 64 with what we call the P160, meaning the new boosters, longer and more powerful, that will enable us to launch even more Amazon LEO satellites per launch, so stay tuned.
Fantastic. David, thank you very much indeed. Congratulations to you, to all the teams and everybody involved in today. Thank you, David. So, Loic, once again, a flawless performance for Ariane 6. Another mission accomplished.
Yes, you can see the relief on the faces of the people at the control center.
It's always a good feeling. Congratulations to everybody involved in today's launch, and particularly to the Amazon LEO teams.
Yeah, thanks to all the teams in ArianeGroup, Arianespace, and all the people involved in this all around the world, and at the Space Center, of course.
At the CNES, and also to the TV crews who have made this, and producers who have made this show possible. We'll see you back here for the next launch, but for now, from me, Katie Haswell.
And from me, Loic Leroy. Bye-bye.
Fin de visibilité de la station Santa Maria.
The launch starts the moment you partner with us, as we go above and beyond to understand your world from orbit, everything you've ever imagined, the value you bring home to Earth, all the lives you seek to improve. So, whatever your goals, however far you want to go, your success is our mission. More than rockets, we launch ambitions. Arianespace, launching ambitions.